application, basically deploy, scale, rolling updates, and controlling of the resources. Right, and it's portable, so it can run anywhere. You can run Kubernetes on like bare metal servers. You can run Kubernetes on VMs which are running on OpenStack. By the way, there is another concept where you can actually deploy OpenStack on Kubernetes. So I think OpenStack has a project called as Cola, which actually does this. You can also run Kubernetes on any public cloud like Amazon. And Google has specifically, they have a service where they only offer Kubernetes on their GCP cloud. You can even run it on, like on a virtual box on your laptop. So the good thing is that since this is a container, right, you don't have like issues that deals with all this nested virtualization and all that. So it's pretty easy to run. But this is how I kind of usually, if I want to test something or quickly validate, so I'll just create a vagrant script. I bring up some virtual box machines and then I just deploy. Then it provides all these other capabilities such as auto restart, auto rescheduling, auto scaling. We will go through when we go through the architecture and we kind of get familiarized with the terms. We will kind of go through some of them. And it is kind of it has like a very tight integration with the the CI/CD environment, and it kind of like integrates pretty well. So some of the key terms. So next slide we have like architecture where we are putting all these things together. But I want to first introduce some of these terms. Right? So on the Kubernetes core components, so the Kubernetes infrastructure itself. So what are the different components that we have, right? So first one is the Kube API server. So this is the one which kind of exposes the northbound APIs to the users or application developers. So this is where like the user of this Kubernetes, they can do all CRUD, the create, read, update, and delete operations. And then you have the kube scheduler. So basically, Kubernetes at a high level, it has a kube master, which is like a controller, and then what you have called as the slave or the minion. It's similar to OpenStack controller versus OpenStack container. So the kube API server, the kube scheduler is the one which kind of schedules the container across different the slave nodes or the minions, similar to Nova scheduler. Kube controller manager is kind of coordinates among all the different all the other Kubernetes services. The container engine itself, that's your like the agent, right, where you bring up container. So basically the container engine is like either the Docker. The Docker is the most it's like the most widely deployed container engine. The other popular option is Rocket. So Rocket is kind of alternative to Docker, and it's by Kubernetes. And the kubelet is like the agent which kind of sits on this minion, kind of talks to the kube master, and it kind of gets like instructions from the kube master, kind of to bring up or bring down the container. And then you have the kube proxy, which kind of facilitates to kind of add on other services, and especially so networking is like an add-on to Kubernetes. So you have like Kubernetes kind of exposes what is called a CNI, container networking interface. It's similar to ML2 in OpenStack. You can add your other add-on plugins, and you can have your own. So OpenStack is like one of the like the CNI plugins which we are providing. And then, as I said, you have the add-ons and other things. So the other like add-ons also includes other monitoring tools like like Grafana and InfluxDB and so on. So what are the key terms, right? So in the case of Kubernetes, the smallest deployable unit in Kubernetes is actually not a container, but it's called as a pod. So pod typically consists of one or more containers, which are kind of tightly coupled to each other. But in most common cases, a pod is like it is one container. So one pod is one container. So some of the things with the properties of pod is that all the containers in a pod, they share a common IP and they also share a common volume. So containers inside the pod, they kind of talk to each other using like a host networking. So basically pod gets IP, right? So we are more concerned with the networking. So for us, that's the key point. So a pod is the one which gets IP and not a container. So you can like create multiple copies of the pod, right, for a given application. for like high availability. So what's a service? So service is think it like a load balancer in front of the pod. So basically you kind of encapsulate all this pod and you kind of expose a service to the user, whoever wants to kind of consume the the application that is offered by that pod. So the replication controller, so in the Kubernetes, it kind of controls how many, so at a given time, so Kubernetes is, it's more like a how do I say, it's like a declarative, so in Kubernetes you kind of say what is your desired state, and Kubernetes makes sure that that desired state is maintained across the system at any given point in time. So the replication controller, it kind of plays a role in this, because you can kind of say how many copies of pods you want at any given point of time, and kind of replication controller takes care that if one pod dies, another pod kind of comes up. I just want to add one more point here, that in the case of Kubernetes, the pod is like, it's handled more like a cattle and not a pet. If a pod can come up and it can go down, you really don't care. Like if one goes down, the RC, the replication controller, will make sure that at any point, if one goes down, it will bring up another pod. It may come up on the same slave node, or it may come up on a different slave node. So deployment is what I said, the desired state, right? It could be for a pod or for a service. Namespace is like it's similar to a project or a tenant. So the labels, selectors, annotations. So labels are, it's a way to identify a resource. So when you bring up a pod, you can kind of add arbitrary labels to it. And when you, and other, resources. So if a service wants to like add a pod as an endpoint, it can use those labels as a selector. You can, like, in one place you can color using labels. And other resources can use those colors, to match that resource and as a selector. Any questions? I need the wireless. I'm still not connected. No, it's that the high speed, because yesterday I was given. Okay, just give me 1 second. I think it's coming from your cache. Okay, any questions till this point? So if we put all these things together, right, so this is like a high-level architecture. So you can see that, so what you see here at the bottom, so this is the master, right, where I have all the controller related services running. Then I have the two minion nodes where the Kubernetes is running. And if you see on the first like minion, so I have like a set of pods. And then there is a service that is fronting all these pods. Similarly, I have like a set of pods running here. The replication controller is the one which kind of controls how many copies of these pods should exist at any given time. And then I can also expose the service to the outside world, right? So somebody like you can think this service as like a front end, which is a web front end, and this is exposed to the outside world. So that's where you can kind of have what is called like like an OpenStack, right? So this is similar to adding an OpenStack floating IP to that service. Any questions? So before I kind of go to the OpenStack integration with Kubernetes, I mean, like we have a lot of these resources on the internet, but I want to quickly kind of glance through that. So basically, Contrail is the SDN controller by Juniper Networks, and it kind of works with like a wide range of orchestration systems. So we have like support for OpenStack, Kubernetes, also Mesosphere, VMware, the vCenter, and also you can use OpenContrail without orchestration. So we have customers who have integrated OpenContrail with their own orchestration system, because for everything, all the operations you can do on OpenContrail, we kind of expose both REST and language-based APIs. Just to kind of quickly talk about the architecture. So what you see at the top, there is a Contrail controller, and it kind of has the components such as config, the control, analytics, and also there is a service server management. And you can horizontally kind of scale multiple controllers for high redundancy and also scaling. And between these controllers, they run iBGP to kind of synchronize the state. And on the compute node, right? So this compute node can be like a Nova compute. It can be, as I said, in the case of Kubernetes, it's a Minion. So we run what is called as a vRouter. vRouter is the forwarding plane component, right? Which kind of where all the VMs of the Docker containers they connect, and vRouter kind of takes care of forwarding. And vRouter kind of talks to the Contrail controller using XMPP. We also have integration with top of rack switches for bare metal integration. So you can have workloads which has to be run natively on top, on a bare metal server, right? There are like Oracle database or there are some legacy applications which you cannot virtualize or containerize. For that, we have an integration with for this kind of a scenario where Contrail talks OVSDB, the controller talks OVSDB to the tower. And also you can provide a connectivity to the external world using the SDN gateway. And in this case, we again talk BGP. So people who are familiar with the networking, right, think Contrail as a big MPLS P router. And you can think of all the vRouters as like a line cards. Right? So that's why because with the Juniper's heritage, it was like a pretty natural choice to kind of use BGP as much as possible. So for us, a virtual network is nothing but L3 VPN like VRF. So when you create a virtual network internally, we kind of create a VRF on the vRouter, and actually the VM or the container it actually connects to that VRF. And for forwarding, we use like MPLS over so we have multiple options. So MPLS over GRE, MPLS over UDP, and also VXLAN. Any questions? So logically, whenever you create a virtual network, so the most, the feature, so one of the important feature what we offer is, like network policies and service chaining. So in the case of Neutron, you have to create like a Neutron router, you have to connect the left network, right network, and all these things. With Contrail, it is like, you have a single construct where you have connectivity plus firewall. And you can also use service chaining where, so with network policies itself, you can have connectivity and, as I said, L4 firewall. But if you want more advanced features, like if you want to do like IDP, you want to connect two networks, right? But the traffic between those two networks, you want to send it through some IPS or IDS, right? Some layer L7 firewall. And the option is, the service chaining, where you can say that I want to connect this network left and right. But any traffic that flows between these two networks, I want to send through this, this VM. So the service firewall, what you see, it's another VM. It has one leg in the left network and another leg in the right. And these are the different services offered by the Contrail. So today, as of today, I think these slides will be shared. I'm not going to go through all this for reference. For the integration with Kubernetes, so what we have introduced what is called as a new daemon called as Contrail Kube Manager, which kind of listens to the API events from the API server. And we also run Contrail controller there, and on the Minium nodes we run vRouter, and we have our own CNI plugin. So whenever we kind of listen to like some interesting event from Kubernetes, like some pod is coming up or going down, we kind of the Kube Manager, it kind of listens to this event. It kind of instructs the Contrail controller using our APIs, and then from the Contrail controller, the respective the vRouter which is running on the Minium node, it kind of gets that instruction. And using the CNI plugin, we kind of connect that component to the vRouter. Yes.
IPAM for perspective, do you manage the IPAM by yourself?
So we manage the IPAM for the cluster, the pod.
And how about the service?
It's given by Kubernetes.
Yeah, so you basically go Kubernetes.
Yes.
And do you also, I mean, of course, Kubernetes has only IP, L3.
Yes.
Is there any deployments where the customers ask for L3?
We can do L2. So in the Contrail, so basically I can show you when we go for the demo. So we have a single plus, like we have only two subnets, right? So you have one subnet for the pod, right, and then you have one subnet for the service. In Contrail by default, if two kind of endpoints, they talk to each other, and if they are part of the same subnet, Contrail has option where they can talk to each other either as L2 or they can also talk to each other as L3. So L3 is similar to how it works in Amazon, right? But we can also do L2 because we use both L3 VPN and eVPN. So we can learn Max as well.
And from a tenant isolation point of view, how do you separate them?
So in the case of tenant separation, it's not covered here, but we have the tenant, the isolation mode, where if you create a non-default tenant, we kind of create a separate pod network for that tenant, and then we actually use like we kind of assign some floating IP to those every pod, so that we can steer the traffic to the service network, because service is going to be all the service IPs will only come from the service network. Right?
And you sort of change the Kubernetes so that it doesn't schedule any pods.
So I can share you more detail offline, but because we anyway use like security groups, right? You can use that to achieve the isolation. So these are like the mappings. I hope I have answered you. Yeah. So these are the mappings, from the Kubernetes resources to the corresponding resource in Contrail, right? So the namespace, as I said, is a project or a tenant. The pod for us, it's like a virtual machine. So we have a virtual machine object. It's not a virtual machine, but we can create object. So the pod maps to that. The service, as I said, so in the tradition, I think in the classical Kubernetes, I think they use Nginx as a load balancer. But for Contrail, we have created, so we have come up with our own native load balancer, which is like in the vRouter itself. Because vRouter, by natively it can do a ECMP, like L4 ECMP. We have kind of leveraged on that, and we have defined a load balancer resource. Then the ingress is a HA proxy because it's a URL based, right? And the network policy, so Kubernetes also has a construct called as a network policy, so that maps to security groups. So how much time I have? 5 minutes? Okay.
Quick question.
Yes.
In this environment, what do you recommend for IDS, IPS types of DDoS attacks?
Yeah, so the question is what type of IDS or IPS, right? Like, because for us it's like we are agnostic of that, so you can use any IDS, IPS which is available in the market. Juniper has like a firewall called VSRX, but you also have other vendors providing these solutions like Palo Alto, Checkpoint.
Yeah, okay, so we can all use it.
Yes. Contrail doesn't care for that. It's just a VM. We just send the traffic to the VM. What it does inside is, it's left to that function. So this is the demo, right? So basically I have, so this is a 3-tier app called as guestbook. So this is like used in most of the Kubernetes like demos. So So there's a front end which is a PHP front end, and then there are two, there's the middle layer is the Redis worker, and then there is a Redis master. And we are kind of exposing that front end outside, right? Because we are putting a egress load balancer. So I'm quickly jump to the So if you see, this is the Contrail web UI, right? So if you see, so there are two networks here. So so there are actually just two networks. So the cluster network is where the pods get the IP, and also the IPs are given out for the service. And the public IP, this is the routable IP. This is the one which is used for for the egress load balancer. And if we see the IPAM, so the IPAM has there are two subnets here. So the service IPAM has a subnet 1096.00/12, and the pod IPAM has the subnet 1032.00/12. If I go back to the so currently I have just this Ubuntu app running. So this is just a, example, kind of a container which I kind of got up. And then what you see the service, what you see here below. So PO is the pod. SVC is the service. The service what you see is this is the Kubernetes service itself, the Kubernetes API server. So I can so now if you see these pods are created for the, let me show you. So if you see these pods are created, you can see there are three front-end pods, there are two Redis master, and there is one Redis slave. And this is defined by the replication controller, the number of replicas we have defined in the YAML. And then you can also see the nodes where these are scheduled, because I have two minions or the compute nodes. So these are kind of scheduled more or less evenly across both of these. And then in addition to that, you can also see the service. So there is a service created for front end, the Redis master and the Redis slave, and the service has got the IPs from these subnets. So this is the subnet which we defined for all the services in the IPAM, right? And if you see, the front end service also has got this 1084.53.51, because for the front end service Kubernetes we have defined a keyword called as a load balance, which makes it it's a egress service. So that's why we also put a routable IP there. So in the example I showed, right, there are in the last, for the front end we put two services. There's a service for the front end and there is a egress. And then you can see the deployment, right? So the front end, the desired is 3 copies, the current is 3. So this is what I was telling about the desired state versus the current state. So if we go back to the, and you can see these on the web UI also, right? I am done. Yeah, I mean, it's just you can keep on thinking and kind of go into this flow. So I'm done unless you have any.